a high schooler at Monte Vista. So today I'm going to be going over how to find a limit at infinity, but it's going to be a shortcut. So why don't we head right on into it? Let's say you're given the limit as x approaches to infinity of x, like let's say 9x to the power of 8 plus 6x to the power of 7 plus 5x cubed plus 2x plus 5 divided by 8x to the power of 7 plus 3x to the power of 5 plus 4x cubed plus 2. And you're asked to find the limit of this. This seems like a pretty terrifying problem. I would probably pee my pants and run off. But no, there's a shortcut. See, if I were to plug in the value of infinity for all of these, if I plug it in for x to the power of 8, it's infinity. It's going to be some infinitely large number. Now, infinity is a very large number, so it doesn't matter how much the coefficient is. But look, this is going to be infinity, this is going to be infinity, this is going to be infinity, this is going to be infinity. They're all going to be infinity, so what's the point of taking it all? Same thing here. If you plug it in, it's infinity, 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 infinity. It doesn't matter. So what you're going to do here is you're going to take the value with the highest power from both the numerator and denominator. But why would we only do that? Why wouldn't we take the second lowest? Well, because in some ways, x to the power of 8 has the most dominance of infinity over all the other ones, just because it has the highest power. You're going to be multiplying infinity out the most and be multiplying with its coefficient. Same thing here. So what's going to happen is this is going to be limit as x approaches to infinity of 9x to the power of 8 by 8x to the power of 7. Usually from here, people just algebraically divide it out and find out the value. So this is going to be limit as x approaches to infinity of 9 divided by 8x. Because if you divide x to the power of 8 by x to the power of 7, all you're going to be left with is an x on the numerator. Then you're going to plug in infinity. See, this is the easy part. You're going to plug in infinity. You're going to get some infinitely large number over 8, because infinity times 9 is infinity. So what's going to happen is an infinitely large number by 8 is still going to be infinity. So your final value is going to be 8. Now there's going to be, oh wait, not 8. Infinity. So what you're going to do, this problem is definitely going to come on whatever test you're going to take, SAT, at least one, just because of how scary it looks. But see, this is a relatively simple problem using the shortcut. You can have other various problems, such as, see, if I were to come to this side over here. Let's say you're given the limit as x approaches to infinity. And by the way, this is not only for infinity, this also goes for negative infinity. I'm just using positive infinity just for the simplicity purposes. Limit as x approaches to infinity of, let's say we have 8x cubed plus 5x squared plus 3 divided by x plus 2 to the power of 3. Now in this case, we already know what the highest power up here is. 8x cubed. So we don't have to do anything for the numerator. We're set. The problem here is on the denominator. We have a function which is cubed. So what are we going to do in this case? I don't want to have to multiply this whole thing out just for this one problem. I'd rather just directly substitute it. So what we're actually going to do is, even if we were to multiply it out, we know that this initial value, when we cube it, it'll be the highest power that you're going to get out of the denominator. So instead of just multiplying the whole thing out, we're just going to take this power and put it on there, and then we're going to get our final value. And let's say there's a coefficient, you're going to cube that coefficient too. So if we do cube that value, we're going to get the limit as x approaches to infinity of 8x cubed from our numerator And if you cube x over here, you're going to get x cubed. Now if you algebraically divide it out, you're going to get 8. Because the x cubed cancel out. So this is another type of problem you can get, possibly, in whatever test you're taking. Now the last one, which is more commonly seen, at least by me, is a square root problem. Where they're going to give you the limit, as x approaches to infinity, of a function square rooted, like 8x squared plus 5x and whatever, divided by some other normal function like 8x to the power of 8 plus 6. Now in this case, I used to get really confused because I didn't know, should I just take the highest power or should I square root it first? Well, in this case, you're actually going to have to square root it first. For simplicity purposes, for the square root, instead of doing an 8, I'll do a 4, just so I don't have to do too much over here. Limit, as x approaches to infinity, of 2x, because once you, and by the way, you don't have to square root its whole function, just the biggest power that's inside of that square root function. So 2x, because when you square root 4x squared, you're going to get 2x, divided by x to the power of 8, which is in the denominator, the highest power. Then you're going to do what we've done for the rest, and it's going to end up in, no, that does not look like an 8, 2x to the power of 8. So it's going to end up being 2x to the power of 7, and it's going to be, once you input the value, 2 by infinity. Now we know any numerical value divided by infinity, which is such a large number, is going to be bound towards 0 because it's going to be an infinitely tiny number. So we usually just approximate that with a 0. Now I hope this shortcut will help you in future tests. I hope you guys enjoyed the video. If you guys haven't already, do subscribe, like the video, and thanks. Bye.